Hi everybody. This video is going to cover section 2 of chapter 6 where we are going to factor trinomials of the form x squared plus bx plus c. So we're going to practice on factoring out trinomials with a leading coefficient of 1 where a is equal to 1, hence the x squared. And then we're also going to factor trinomials that have a common monomial factor by factoring that sucker out and then factoring the resulting trinomial. Now, all the resulting trinomials that we are going to factor are going to be quadratics, which means that they will have a leading coefficient of a degree of 2 and a leading coefficient of 1. Okay, so let's start here. This is one of the examples you're going to find in your homework, and here we need to list all the factors of negative 42. And here they are. Notice, negative 1 times 42 is negative 42. Negative 2 times 21 is negative 42. Negative 3 times 14 is negative 42. Negative 6 times 7 is negative 42. Similarly, 6 times negative 7 is negative 42, as is 3 times negative 14, 2 times negative 21, and 1 times 2. Notice that 5, 4, and 5 are not factors of 42. When we get to a point where basically one number is the absolute value, one number is consecutive with the absolute value of the other number, then we know that we've gone as high as we can go. Okay, let's take a look at another one. Here are all the factors. Here we're going to list all the factors of 56. And here we go. 1 times 56 is 56. 2 times 28 is 56. 4 times 14 is 56, as is 7 times 8. Since these are consecutive, we don't need to go any higher. And then also the negative of both numbers. Negative 1 times negative 56, negative 2 times negative 28, negative 4 times negative 14, and negative 7 times 8. Now notice that when I'm computing the factors of a negative number, one of the factors is positive and the other factor is negative. If the number happens to be positive, then they are either both positive or they are both negative. Okay, another example that you're going to be asked in this particular lesson is to find all the factors of 12 that say sum to 4. Now, or that sum to negative 4. Now, the best thing to do before we do that is perhaps to list all the factors of 12. So let's go ahead and do that. So the factors of negative 12, correction, that was negative 12, not positive 12, are negative 1 and 12, negative 2 and 6, negative 3 and 4. Well, that's as high as we need to go. So then we're going to have 3 and negative 4, 2 and negative 6, and then 1 and negative 12. Now, this right here sums to 11. This sums to 4. This sums to 1. This sums to negative 1. 3 times negative 4, or 3 minus 4. This sums to negative 4, and this is the one they want. So the factors of 12 that sum to negative 4 would be 2 and negative 6. And of course, this sums to negative 11. But now we can actually use this table to actually figure out the rest of the problems that we have here. Here we want to find out the factors of 4 that sum to 11. Well, here they are, and that would be negative 1 and 12. And then finally, factors of 4 that sum to negative 1, that would be 3 and negative 4. Now, why in the world are we doing all this stuff? Well, it turns out that this is a tool that we are going to use to actually solve solve trinomials of the form x squared plus bx plus c. All right, and that's actually, let's just go ahead and take a look at one. Let's take a look at, or let me actually multiply x plus 4 times x minus 5. I don't like. Let's do x plus 4 times x plus 5. Okay, that'll be x squared plus 5x plus 4x plus 20. Now notice that 5 and 4 are factors of 20. 5 times 4 is equal to 20. And then 5 plus 4 is equal to 9. All right? And if I wanted to simplify this, this would be equal to x squared plus 9x plus 20. Now suppose that I actually wanted to take this and write it as a product of two binomials. Let's suppose I'm started with this. I started here, and I want to figure out what this is. So I don't know what this is. How would I do that? Well, I could rewrite this as x squared plus 5x plus 4x plus 20. And then I could actually do my grouping. This would be x squared plus 5x plus 4x plus 20. This has a common factor of x. And this has a common factor of 4. And I can do then I can, do the distributive property, and again with our factoring, but with our grouping, and I would have x plus 4 times x plus 5. But also what I want you to see, if this is 20, then it turns out that the solution is going to be of the form x plus something, or x plus or minus something, times x plus or minus something. Okay, and what I want to do is I want to find factors of 20 that sum to 9. Okay, and those factors would be 5 and 4. So I'll put a 4 here and a 5 here, or I can change the order. It doesn't particularly matter. And that is basically the motivation behind the procedure that I'm going to show you right now. Okay, so here's step 1. Find an integer pair. Okay, so remember we are going to factor x squared plus bx plus c to something. We want to find integer pair factors of c whose sum is b. Okay? Now, it turns out that if c is a positive number, then b will both be positive numbers. And here is an example. If c is equal to 6, then our factors are going to be positive, and they need to sum to 5. And factors of 6, that's positive numbers of 6 that sum to 5, is going to be 2 and 3. Okay, if c is positive and b is negative, then both of the factors must be negative, because minus 3 plus minus 2 is equal to 5. And finally, if c is negative, then one factor is positive and the other factor is negative. For example, here we have x squared minus 5x minus 6. Since c is negative, we know that one has to be negative and one has to be positive to produce a negative 6. Then we want to find those factors of 6 which will sum to minus 5, and that would be minus 6 plus 1. And of course, we can also, if this term is positive, then we want to find those factors of 6 that will sum to positive 5, which would be plus 6 and minus 1. And to see that, and actually to see that this works out, we can FOIL this, and we will have x squared plus x minus 6x minus 6, x minus 6x is minus 5. X squared minus 5x minus 6. Okay, so best thing we could do is do some practicing here. So let's take a look at this one right here. Okay, so here we want to factor this trinomial. Okay, and here we have a 12. So we want to find factors of 12, of positive 12. Okay, and that will be 1 and 12, 2 and 6, 3 and 4, negative, should be a 12, negative 1 and negative 12, negative 2 and negative 6, negative 3 and negative 4. Well, we want them to sum to 8, okay? So the only factors that will sum to 8 are 2 and 6. As a consequence, this will factor to x plus 2 times x plus 6. Okay? And to verify that works out, we can FOIL that, and we would get x squared plus 6x plus 2x plus 12, and that will give us x squared plus 8x x plus 12. So it's pretty easy to check. For this one, we need to find factors of negative 20 that sum to positive 8. Now the factors of negative 20 would be negative 1 and 20, negative 2 and 10. 3 doesn't divide 20. 4 does, negative 4 and 5, and we're done. So now we can do the opposites. Positive 4 and negative 5, 2 and negative 10, and then 1 and negative 20. And the question here is, of which factors of negative 20 sum to 8? And you can see these right here. So we can write this as y minus 2 times y plus 10. And to verify that is correct, we can FOIL this. We will have y squared plus 10y minus 2y minus 20, and that will reduce to y squared plus 8y minus 20. Okay, let's do a third. Okay, here we have x squared minus 3x minus 10. Now notice here that we have a minus sign. So as a consequence, we know that one factor has to be positive, one factor has to be negative. That means that our two binomial products are going to have the form x plus something times x minus something. And now we just need to figure out what the factors of 10 are, of negative 10. So for negative 10, the factors are negative 1 and 10, and then negative 2 and 5. Does 3 factor? Nope. Does 4 factor? Nope. 5 does factor, so we can actually then write down 2, negative 5, and then 1, negative 10. So which of these add up to negative 3? Well, 2 minus 5 is 3, so those would be the choices. So we can put the 2 here, and we can put the 5 here. Okay, and of course there's no reason why we also can't write this as x minus 5 times x plus 2. Produces the exact same result. And then finally, we have a squared minus 11ab plus 30b squared. So notice that I have a plus sign here and a minus sign here. So this is going to be of the form a minus something times a minus something else. But now we need to figure out the factors of positive 30b squared. Well, that would be b and 30b, 2b, or not 2b, 15b, 3b, 10b, 5b, 6b. And that's as high as we can go. So now we can do negative 5b, negative 6b, minus 3b, minus 10b, minus 2b, minus 15b, and then finally minus b, minus 30b. Okay, so one question, do you really have to do all these things? Well, all these factors? Well, no. Since we know that they're going to be negative numbers, we can actually exclude these. We know that these aren't going to be the factors. So we can actually exclude those. The other ones we will probably need to include. Okay, and which one of these will sum to 11? Well, this one right here. This one right here sums to 11. So we're going to have minus 5b, minus 6b. Does it work? Well, let's find out. A times a is a squared, minus 6ab for the outer, minus 5ab for the inner, plus 30b squared for the last, and there you go. Okay, so that's pretty much your approach for solving trinomials where the leading coefficient happens to be 1 and they are of degree 2, which basically means solving a quadratic expression with a leading coefficient of 1. All right, so what about the case where you have a trinomial with a greatest common factor that happens to be a monomial? Well, let's take a look at this sucker right here. Here we have 5x cubed minus 15x squared plus 10. And we can actually go through our procedure to find the greatest common factor, and we would find that it is 5x. So what do we do? Well, that's what we do. We find the greatest common factor. There it is. Next, we actually want to factor that greatest common factor out. So it's going to be 5x times whatever I need to get 5x cubed, which will be x squared, times and then 5x minus 5x times whatever I need to multiply that by to get 15x squared. That's just 3x. And then plus 5x times whatever I need to multiply 5x by to get 10x, and that would be 2. There you go. Now I have a trinomial, well, basically a quadratic equation, a quadratic expression with the leading coefficient of 1. So then I can use the tools that I used before to factor this out. Now notice I have a plus 2 and a minus 3. So that means that this is going to be equal to x minus something times x minus something else. Okay, so we need to find factors of 2, negative factors of 2 that sum to 3. Well, 2 is a prime number. There's only one collection of negative factors of 2. Negative 1, negative 2. So one of these will have to be 1, the other one will have to be 2. And of course, we always want to include the 5x, which is our last point here. Make sure you include the monomial term. Okay? And obviously the order doesn't matter. Okay? So that's the approach. However, there's one important thing that you need to that you need to consider, and that is that not all trinomials can indeed be factored. Okay? Some of them cannot be factored. And we will talk, and I think I have a case for you in that particular case. When does that occur? That occurs when there are no factors of the C term that can sum to the B term. Let's consider the expression x squared plus 4x plus 2. Okay? What are the factors of 2? Well, basically 1 and 2, and we only care about positive factors. Look, there is negative 1 and negative 2. This sums to 3. This sums to negative 3. There are no factors of 2 that sum to 4. So this cannot be factored. And yes, you will have a homework problem that will not be factored, and you need to figure out where that is in your certification. All right, so, there it is again. Okay, so here is an example of factoring trinomials. So the first thing that we need to do is figure out what the greatest common factor is. And in this particular case, the greatest common factor is going to be 10 times y cubed. Notice that it's basically going to be equal to this coefficient and then times y evaluated, raised to the exponent of this value minus 2. And does that work? Well, let's find out. We have 10 y cubed. Okay, to get this, we'll multiply that by y squared minus 2 times y. That will give me my 20y fourth. And then minus 8y. Now, notice here that we have a negative c here. So this is going to factor into, let me get my pen back. This is going to factor into a y plus something times a y minus something. And those somethings are going to be factors of negative 8 that sum to negative 2. So what are our factors of negative 8? Well, let me see. We have negative 8 and 1. Okay, but that sums to negative 7. So notice to get a negative 2, I want the negative factor to be larger than the positive factor. Okay, what about negative 4 and 2? Negative 4 and 2. Well, negative 4 plus 2 is negative 2. So that's what we're looking for. So this one we will have plus 2 minus 4. And then y squared is y squared minus 4y plus 2y gives me minus 2y. And I have my minus 8. And I also need to remember to bring down the 10y cubed. And there it is factored. All right, so let's take a look at b. Okay, b is 3y to the 6th power plus 33y to the 5th plus 90y to the 4th. What is the greatest common factor here? Well, it's going to be 3y to the 4th. That will give me a y cubed here. So the GCF is going to be 3y to the fourth. When I factor that out, I'm going to have 3y to the fourth times whatever I need to get 3y to the sixth, which would be y squared, plus whatever I need to get 33y to the fifth. Well, 3 times 11 is 33. Y to the fourth times y is y to the fifth, plus whatever I need to get 90y to the fourth. Well, you already have my y to the fourth, so I just need to multiply that by 30. All right, and that means I'm going to have 3y to the fourth. Now notice that I have a plus sign here and a plus sign here. So this is going to be y plus something times y plus something else. What's that something going to be? We need to find positive factors of 30. Okay, well, 1 is 1 times 30. That sums to wait a second, this is not this is a mistake. This should be 11, not 33. So here I have 1 times 30. That's 31. That's not going to work. What about 2 times 15? No, that's 17. What about 3 times 10? No, that's 13. 4 does not divide into 30. What about 5 times 6? Well, that is 11. So this right here would be the factors that we're looking for. 5 times 6, and there we go. We're done. Can you check? Well, yeah, because you can do FOIL here, which give you y squared. 6y plus 5y is 11. 5 times 6 is 30. You can multiply this back in. 3. Here you will have 3y to the 6th, 33y to the 5th, and then 90y to the 4th. And that brings us to the one problem that you will find in your homework. And it looks something like this. Here we have the area in square inches of a rectangle. And it's given by this function right here. Okay? And you know that the length of the area of the length is going to be n plus 8. And we need to find the width. Now remember, the area of a triangle is going to be equal to the length times the width, which is going to be n plus something, and that has to be equal to n squared plus 11n plus 24. So we need to find factors of 24 that will sum to 8. No, I'm sorry, that will sum to 11. Well, we know one factor, that happens to be 8. In that case, the only other number has to be 3, because 3 times 8 is 24. If we sum them, we get 11. So your answer is going to be n plus 3. That will be your answer for this particular problem. Okay, and then I have one more example, and here it is. We want to factor the trinomial x squared plus xx plus 30. Okay, well, we have a plus sign here, a plus sign here. So we're going to have x plus something times x plus something else. And the only positive factors of 30 are 1 and 30, 2 and 15, 3 and 10, 4 does not factor 30, but 5 does, 5 and 6. And since we have consecutive numbers here, that's as high as we can go. Okay, 1 plus 30 is 31, 2 plus 30 is 17, 3 plus 30 is 13, 5 plus 30 is 11. There are no factors of 30 that sum to 6. None of these equal 6. As a consequence, this is not factorable, or at least not factorable with the tools that we have today. And there you are. And these are all the examples that I have for at least this portion of the video. Stay tuned, and I will get Hawks up and running. Okay, so here we are. Here we want to factor x squared plus 12x plus 32. So notice that we have a positive, a plus here and a plus there. So that basically tells us that our answer is going to look like x plus something times x plus something else. So we want to find all of our positive factors of 32. Okay, and we want to find the ones that actually will sum to 12. So the factors would be 1 and 32. Well, they sum to 33. That won't work. 2 and 16. That sums to 18. 3 and 8. Well, that sums to 12. So that must be it. Now we could go further. Wait, that's not 3 and 8. That's 4 and 8. 3 doesn't divide into 32. Okay, what about 5? No. 6? No. 7? No. So these are it. 4 and 8. So we could put a 4 here and an 8 here, and we are done. Okay, let's look at another one. Next. Okay, now this one, we have a +2 minus 24. So C is negative. This means this is going to be of the form x plus something times x minus something else. On top of that, we want this to be positive, so we want we're looking for factors of negative 24. Okay, we want this to be positive, or the larger factor to be positive, so that we actually get a positive 2. So let's go ahead and walk through our factors. You can almost look at that and get an idea what it is. Well, let's look at 24 and 1 and negative 1. That will give me negative 23. Negative 2 and 12 will give me a negative 10. Negative 3 and 8, I'm sorry, positive 10. Negative 3 and 8 will give me a positive 5. Negative 4 and 6 will give me a positive 2. So these are the factors I want. I want a negative 4 here, and I want a 6 there. And there you go. Okay, this one, we have a positive coefficient here, or a positive C, but a negative B. So since the C is positive, they must be the same. Each factor must have the same sign, and since this is negative, that sign must be negative. So this is going to have a trinomial of the form x minus something times x minus something else. And they need to be negative factors of 35 that sum to negative 12. Okay, so negative 35. Okay, no, negative factors of 35. So negative 1 and negative 35, that works. Negative 2 will not, since it's an odd number. Negative 3 will not. Negative 4 will not. What about negative 5? Negative 5 and negative 7. They multiply to 35, and when you sum them together, you get negative 12. So that's what this would be. This would be x minus 5 times x minus 7. Okay, and then we'll do this one, since basically this gives us the last case. Here we have a negative and 30, but then we have a negative x. So since we have a negative 30 here, we know that the factored version is going to look like x minus something times x plus something. Furthermore, since the b value is negative, we know that we want the negative factor to be larger than the positive factor. That way, when you add them together, you get a negative number. So we want to find all the factors of 30 where the negative factor is larger than the larger factor. So that would be negative 30 and 1. That would give us negative 29. 2 and negative 15. That would give us negative 13. 3 and negative 10 will give us negative 7. 4 doesn't divide. 5 does. 5 and negative 6 gives us negative 1. So we want this to be a 6 and this to be a 5. let's see if I'm right. Yay me, I'm right. Okay, let's see what else we have. Okay, those are just all the factors of 25. Actually, it would be 1, 1. That actually would be 1, 25, negative 1, negative 25, negative 5, negative 5, and 5, and 5. Okay, here's the one where they already gave us one term. It's going to be a 6, so we actually had to find something that we want to. So we have b plus 6. The other form, that should be a b. The other form is going to be b minus something that will produce for me a positive 4, and that minus something. So we need to find a factor of 12, or we need to find that number which multiplied by 6 will give us 12, which will be a negative 2, and then 6 minus 2 is 4. So that's how that one will work out. And then here is the one I want to look at, and is this one right here. Here we have d squared minus 8d plus 6. Okay, so this is going to be of the, since we have a plus here and a minus here, this is going to be of the form d minus something times d minus something else. Something else. All right, so we need to find factors of 6. Negative factors of 6. Well, actually, in this case, negative factors of 6, that will sum to 8. Now we have negative 1 times negative 6, that sums to 7. Negative 2 times negative 3, that sums to 5. And that's pretty much all that we have. As a consequence, there are no factors that sum to negative 8. As a consequence, this is not factorable. And we can go ahead and click that, and that should be correct. There you go. And that is all that I have for this particular lesson. If you have any questions, please feel free to contact me. And this is Bob Boyle, signing off.